Have you ever just stopped and wondered what makes an AI like GPT so incredibly powerful? Well, a huge part of the answer is this revolutionary idea called self-attention. It's truly the engine driving all of modern AI, and today we're going to break down exactly how it works. So let's kick things off with a really fundamental question. How can a machine read a long, complicated story and actually, get it? How does it connect what happens at the beginning of a paragraph with what happens at the end? For the longest time, this was one of the biggest roadblocks in AI. Okay, so before we can really appreciate the breakthrough, we have to understand the problem it solved. And a great way to think about it is what I call the index card problem. This was the fundamental bottleneck for all those early AI models. Just imagine this for a second. Imagine trying to cram all the information from an entire library onto one single tiny index card. Sounds impossible, right? Well, that's exactly what old AI models were forced to do. They had to squish a whole sentence down into one fixed chunk of data, and it created this massive bottleneck. So that little index card we're talking about, in text speak, that's called a context vector. And because it was a fixed size, it just couldn't hold enough information. I mean, research showed that for any sentence longer than about 30 words, the model's performance would just fall off a cliff. It would literally forget the beginning of the sentence by the time it got to the end. So how did AI get past this massive hurdle? Well, the answer was a game-changing idea called the attention mechanism. And honestly, it changed everything. Now, at the heart of this whole thing are two concepts we really need to get straight: inter-sequence attention and intra-sequence attention. That first version, the one that solved our index card problem, that was all about inter-sequence attention. And inter-sequence attention does pretty much what it sounds like. It figures out the relevance between two different things. Think about a human translator looking at an English sentence while they're writing a Hindi one. The model could now pay attention to specific English words as it generated each new Hindi word. It no longer had to rely on that one blurry summary. So here's the quick and dirty on how it works. For every new word it's about to write, the model forms a query, kind of like asking itself, okay, what part of the original sentence is most important for me right now? Then it scores every single word in that original sentence for relevance. And finally, it takes a weighted sum of those words to build a totally custom context vector, just for that one step. No more single index card for everything. But, this was really just the beginning. The real revolution, the one that led to where we are today, happened when researchers took this brilliant idea of attention and turned it inward. Look, that first attention mechanism was awesome for tasks like translation, where you're always comparing two different things. But it left this giant, gaping question. How can a model possibly understand all the complex grammar and meaning inside a single sentence? How does it figure out that in "the cat chased the mouse because it was fast," the word "it" refers to the mouse, not the cat? And the answer to that question is self-attention, which you might guess is a form of intra-sequence attention. The name really says it all. It's a mechanism that lets a sequence look at itself, relating different words within it to build a much richer, deeper understanding of itself. Okay, I've got the perfect analogy for you. Traditional attention is like a Spanish to English dictionary. You're always looking up a word in one language to find its meaning in another. You're comparing two different things. But self-attention, that's like an English-only dictionary, where every word is defined using, other English words. It builds all of its meaning from right there inside itself. So how does this whole internal comparison thing actually work under the hood? It turns out it's surprisingly elegant. This table really drives the point home. Something like Luong Attention, which is a classic early type, is inter-sequence. It works across two different sequences. But self-attention is intra-sequence. It's all about one sequence comparing against itself to figure out its own internal logic. And what's so cool is that self-attention wasn't a totally new invention, but more of a brilliant repurposing of existing ideas. For every single word, the model generates 3 new special vectors. There's a query vector, which is like the word raising its hand and asking, hey, who in this sentence is relevant to me? Then there's a key vector for every word, which acts like a label that says, here's what I am. And finally, a value vector, which holds the word's actual meaning. The model just matches the query from one word with the keys of all the other words to find the best matches, and then it sums up their values. And that, right there, is the origin of the now famous QKNV. And this is what that whole QKV machine actually looks like inside the model. The diagram on the left, that's the core engine. It's called scaled dot product attention. But the real magic is on the right, multi-head attention. See, instead of doing this process just once, asking just one question, the model runs a bunch of these in parallel. It's like having multiple heads all looking at the same sentence at the same time, but each looking for different things. One head might track grammar, another might follow who's doing what to whom. It lets the model capture all these incredibly rich relationships all at once. And this powerful new building block, multi-head self-attention, well, it became the foundation for a complete and total revolution in AI architecture. And this is it, the famous transformer architecture from that groundbreaking paper, Attention is All You Need. It's basically built by stacking those multi-head attention blocks we just talked about. This design didn't just improve on the old models, it completely replaced them. It threw out the old, slow, step-by-step methods and relied entirely on self-attention, which meant it could process language way more efficiently and in parallel. And believe me, the impact was fast. I mean, really fast. In 2014, Attention was just a little add-on to help out older models. Then boom, 2017, the transformer paper drops and makes self-attention the main event. And from 2018 on, models you've definitely heard of, like BERT and the entire GPT series, took that architecture and, well, they changed the world. And that's why really getting this one concept is so important. There's that old saying, right? If you have 6 hours to chop down a tree, spend the first 4 sharpening your axe. Learning about self-attention is sharpening the axe. Once you get this, I promise, understanding the rest of modern AI gets a whole lot easier. All right, let's wrap this up with the key takeaways. So, what is self-attention? Simply put, it's a way for a sentence to understand its own internal context. Why is it so different? Because it compares a sequence to itself, not to something else. And why does it matter so much? Because it's the absolute core component, the engine, inside the transformer architecture that powers basically every major AI breakthrough you read about today. You know, the paper that kicked off this whole revolution had a pretty bold title, Attention is All You Need. It really makes you think, if teaching a machine to look at itself was the key to unlocking the secrets of language, what other incredible breakthroughs are just waiting out there for us once we discover the next fundamental self in AI?